In this video, we're going to be learning about the applications of the extrema. Now, what are extrema? Extrema are kind of minimum or maximum of some function. Now, as we learned last time, we learned how to find these minimum or maximums or extrema. In this video, we're going to be actually putting them to use in the real world. So, for example, in the real world, you have a sheet of metal that has an 8 centimeter wide bottom and a 12 centimeter height altitude. And you want the maximum size of rectangle you can cut from it. So you have a triangle measured 8 by 12, and you want to cut the largest possible rectangle, the largest area of rectangle. So, what is the dimensions of the rectangle that will yield the greatest area? That's what we're kind of trying to find out. For a problem like this, we have to follow kind of like an outline. So the first step is identifying what needs to be maximized. In this case, it will be the area of the rectangle. Now, the second step, now that we identified it, now how do we get to that place? How do we get to the thing that we're trying to maximize? In this case, area of a rectangle. So ask yourselves, how do you get the area of a rectangle? Well, it's base times height. And we'll label it base times height. Great. Now we will express area as a form of that. Area equals base times height. And now the next step, to express one of these variables as a function of the other. So for this, we're going to need a bit of intuition. So basically, if we take one side of one of these rectangles, we know that half of 8, which is this length over here, would equal 4. And we know that 12 stays the same on the altitude. Now we can see that over here we have a line. And it would be really nice to know the slope of that line. So how do we calculate slopes? Slopes are rise over run. In this case, rise is 12, so 12 over 4 equals 3. So we would have the slope 3 or negative 3. Over here it's 3 and negative 3 over here. And that is our slopes. So with the slope of negative 3, or negative 3, then we can express h as a function of b. So for example, if we put this on a graph, if we just put one of these side lengths on a graph, like that, then how do we get, and this axis is the base, well, something like x, and this would be height, then how would we get height? So now we know that it's a slope of 3 and it's passing through the origin. So that function would yield us fx equals 3x, a simple function over there. So basically, when we have a distance, we go up, we multiply that distance. For example, let's just take a 2, and we go up by, and we take 2, multiplies it by 3, and we go up. So that's 2 times 3, and this 2 times 3 is 6. This distance will be 6. And then if we take 3, 3 times 3 is 9, that distance will be 9. So now that we know this, we have to get x. So if we kind of graph this triangle, then we would have something like this. And this side length would be kind of our 3x. Now how do we get to this point? Because this is the point that most matters. So that's what we're trying to get to for the height. So we know, since the base is 8, that this side, these sides, is 8 over 2, which is 4. That's nice. And then we know that this since splitting it from the middle, is b over 2, which is also nice to know. And what we really want to know is this, so we can substitute it back into this function. So now we know that this is 4 minus b over 2. So now, if we substitute this into this, we would get h equals 3 times 4 minus b over 2. And if we simplify that, we would get 12 minus 3 over 2b. And now, since we have this, since we've expressed h as a function of b, we can substitute h in this expression for this expression. And substituting h for this expression, it would get us b times 12 minus 3 over 2b, which would get us b times 12 minus 3 over 2b squared. And that is our area. And just like we learned last time, we want to maximize this expression. So what value of b will give us the highest area? And since we know it already, we just take the derivative of a, which will get us 12 minus 3b. And since we now have the derivative, we just make it to equal to 0 for us to get the critical points. And b would equal 4. So now that b equals 4, we can substitute b back into this expression we made to find h. So 4 divided by 2 is 2, 4 minus 2 is 2, 2 times 3 is 6. So h would equal 6. And that would give us our answer. So this process is first defining this what to be maximized. If there's two variables, express it into the other. So we can use a as one variable. So then we can solve it for 0 and to give us our critical points.